Assalamualaikum. Welcome to my YouTube channel. Today topic is discovery of noble gas. The noble gases were not known until 1894. A couple of years earlier, the English physicist Lord Rayleigh discovered that the density of nitrogen gas obtained from air was noticeably greater than the density of the nitrogen obtained by decomposition of nitrogen compounds. Helium concluded that one of these two nitrogen sources was contaminated with another substance. In 1894, Rayleigh, in collaboration with William Ramsay, passed atmospheric nitrogen over hot magnesium to remove the nitrogen as magnesium nitride Mg3N2 and obtain a non-reactive residual gas. They placed this residual gas in a sealed glass tube and passed a high voltage electrical discharge through it to observe the emission spectrum of the corresponding atom. The spectrum showed a series of the red and green lines and was unlike that of any known element. Ramsay and Rayleigh concluded that they had discovered a new element which they called argon, from the Greek word argos meaning lazy, referring to argon's lake chemical reactivity. Before the discovery of argon, some lines in the spectrum of Sun were ascribed to an element not yet known to Earth. This element was called helium, from the Greek helios meaning sun. In 1895, Ramsay and the Swedish chemist Per Theodor Cleve, working independently, announced the discovery of the helium gas in the mineral cleaved uranium ore by identifying the spectrum of helium. In 1898, Ramsay and Travers carried out systematic refraction of liquid argon, and they isolated a new element in the first fraction, which gave a number of red lines in the spectrum. It was named neon, meaning new. The other fractions were found to contain krypton, meaning hidden, which gave green spectral lines, and xenon, meaning strange, which gave a blue glow. Radon was discovered in 1990 as a gaseous decaying product of the radium. Isolation of the noble gases. Helium occurs to the extent of up to 8% by volume in natural gas. Helium is generally isolated from the natural gas. Helium has a lower boiling point than any other gas. It is readily obtained by cooling natural gas to a temperature at which other gases are liquefied or solidified, leaving helium in the gaseous state, which can be pumped off. Helium may also be obtained by heating the mineral monazite alone or in the presence of dilute sulfuric acid. Radon is a radioactive distinguishing product of the radium. The noble gases are separated and isolated from the air by fractional distillation from liquid air by chemical methods. Isolation of the inert gas from the liquid air. Liquid air contains helium, neon, argon, krypton, xenon, nitrogen, and oxygen. This method is based on the difference in the boiling point of different constituents of liquid air. The noble gases are separated from one another and also from oxygen and nitrogen by fractional liquefaction and evaporation at reduced pressure. The boiling points of the noble gases, along with those of oxygen and nitrogen, are as boiling point boiling point in Kelvin and degree centigrade: helium, neon, nitrogen, oxygen, argon, krypton, and xenon. Some important conclusion from the above table. Helium and neon have very low boiling points, and hence during the process of helium and liquefying air, helium and neon remain in gaseous state while the other constituents will change into the liquid. There is the only difference of the plus 3K in the boiling point of oxygen and argon, and hence these two gases are collected more or less as a single fraction. Krypton and xenon have fairly high boiling point as compared to those of nitrogen, oxygen, and argon. Therefore, krypton and xenon are always found in less volatile portion of the liquid air and are always easy to separate from the other gases. The plant used for isolation of the noble gases consists of two fractionation columns. lower fractionating column, and upper fractionating column. These columns are provided with the baffle plates. On the inner side, there is a reservoir between these columns. This reservoir contains liquid oxygen. Air free from carbon dioxide and moisture is compressed and cooled and is then introduced into the lower fractionating column near its bottom. The air expands and as a result cools down further. The cooling results in the liquefaction of less volatile gases, namely oxygen, argon, krypton, xenon, radon, and a little of nitrogen. These gases are reflected at the bottom of the lower fractionating column. Thank you very much.